Control Logic's Maintainer Certificate. Introduction. Programmable logic controllers, communications, and logic. Objectives: emulate a virtual PLC for simulation, and communicate to a PLC in order to program logic. In order to monitor or edit PLC code, you need a PLC with power applied, you need a computer that has the programming software installed, and you need a communication setup, and that includes hardware and cabling as well as drivers configured to allow your computer to talk to your PLC. So let's start with the PLC. Most of the time when you deal with a PLC, it's going to be a piece of hardware that's installed in an electrical cabinet in a factory. But for these tutorials, we're going to be using an emulated PLC, which means a virtual PLC, using the software package RS Emulate. Here's the icon for RS Emulate, or we could search for it. Emulate. Studio 5000 Logix Emulate. Now I've already configured Logix Emulate for a chassis configuration that we're going to be using throughout a lot of these tutorials. I have a processor in slot 2, a simulated input card in slot 3, and a simulated output card in slot 4. On to communications. Usually when you communicate with a PLC, you'll need some kind of physical cable. Most of the time in this day and age, it's an Ethernet cable, though sometimes it could be a USB cable. We used to have all kinds of different esoteric cables to communicate with older PLCs, and sometimes in plants with older PLCs, you'll still have these. But given that we're dealing with an emulated controller right now, we won't need a cable. We'll just need to open the communication software, and that's called RS Links. If we click on RS-Who, we can see a number of different drivers over here. I have an Ethernet driver, for example, and this driver, which is a virtual backplane. If I click the plus sign to expand this, we can see my emulated processor along with the I/O simulators in slot 3 and 4. Again, 3 is set up for inputs currently, 4 is set up for outputs. Now that I have my communications established and I can see my processor, I'm going to open the developer environment. That's the tool that I use to write my software. And with this series of processor, that is Studio 5000. Here's the icon for it here. Also, I could start typing Studio 5000 and open it up. I'm going to want to open the file that's currently running on my emulated processor, because in this example I do have a program running in there. So I'm going to select Open from Upload. We can see a version of RS Links open, and I'm going to open the driver for my virtual backplane and select my emulated processor and hit Upload. Studio 5000 is going to give me the option to upload the file into whatever program that opened up, or to select a new file that I want to upload into. And just in order to save it to a fresh file, I'm going to select the file and then type in a name of my choosing. My test 0, for example. Hit select, and now the program that's resident on the emulated processor will begin uploading into Studio 5000 into mytest0.acd. I'm going to click yes. Now that I've uploaded the program from the processor, I've currently connected to it, and I can tell I'm connected because my online toolbar is showing the processor state. The processor is currently in remote run mode. If I was not online or connected to the processor right now, it would display offline, which means disconnected from the processor. And I can go down here into my main program and look at the code that's resident on the processor, or look at the state of various tags, which are variables inside the processor. And we'll discuss these things later on. If I wanted to disconnect from my processor, I would probably first make sure that I saved my file. And then I could go to my online toolbar and click Go Offline. And now I'm not currently connected to the processor any longer. So to conclude this introduction, I'll reiterate the three things that we need in order to communicate to and to program a PLC. First, we need the PLC itself with power applied. In this case, we're using a virtual emulated processor. Second, we need the communications setup. That includes any cabling or driver setup in order to communicate between your computer and the processor. And last, we need our developer environment, which in this case is Studio 5000 for the Logic series of Allen Bradley processors.